Alrighty, hello, lovely year nines. Hopefully, you've all up to date with everything from chapter 4 with factorization, and we're starting our new chapter today on solving simple linear equations. So, it's just going to go through some key ideas to start. So, when solving an equation, you want to find the value of the unknown that makes the equation true. So if you have a look below here, we've got solve 3x plus 5 is equal to 20. So 3 times a number plus 5 is equal to 20. So we're saying, well, what is that number x? Okay. An equation has two sides, both of which are equal to one another. The goal is to isolate the unknown value. So in that first example, I want to figure out what the x is. And you achieve this in a series of steps where you perform the same operation to both sides of the equation. And then it's also really important that you verify your solution by substituting your solutions back into the original equation. So you can pretty much just determine straight away whether you've got the answer right or wrong. And you can have solutions that are integers, fractions, decimals, negatives. So don't be too alarmed if you've got a weird looking solution, but if you can verify to see if it's right or wrong. So let's have a look at some examples here. Okay, so first one here, we've got 3x plus 5 is equal to 20. Now, when you're setting out your work, you want to do it in a series of steps where basically your equal signs are directly below the previous ones. Okay, so in this first example here, I want to get rid of the x. So 3 times a number plus 5 is equal to 20. So the last thing we did there was plus 5. So I want to do the opposite operation of that. I want to take 5 from both sides. So if I do 20 take 5, that gives me 15. If I take 5 from there, I'm just left with 3x on that side there. And in the next step down below, I've got 3 times a number. And so basically the opposite of timesing by 3 is to divide by 3. So if I divide by 3, I've just got my x value, and if I do 15 divided by 3, I get 5. Okay, so let's put that back into the original equation. 3 times 5 is 15, 15 plus 5, 20. You beauty. All right, next one. So essentially, just going to do the opposite operation. Here I've got a times 5, take 7. So I'm going to do the opposite of that. I'm going to do plus 7 divided by 5. So let's step that out. 18 plus 7 is 25. And that gets rid of that minus 7. And then I'm going to divide by 5. So 25 divided by 5 is 5. So x is 5. Let's test it out. 5 times 5 is 25. 25 takes 7 is 18. Yep, we're spot on again. In part C here, pretty much looks similar-ish to A and B. However, it's sort of done the other way around. So we've got the number first and then the 2x. Always get rid of the loose term first up. So I'm going to take 3 from both sides. So 15 take 3 is, the reason why I take 3 is because that is a positive 3 there. And that still leaves me with that minus 2x. That negative belongs to that 2x there. And then, whoop, apologies here. And so I want to get rid of the 2 and the negative as well. So I'm going to divide both sides by minus 2. And in doing that, 12 divided by negative 2 is minus 6. So let's test it out. Minus 2 times minus 6 is positive 12. 3 plus 12 is 15. Yep, we're spot on there. Cool. Now that brings us down to our next series of equations here. So difference between these ones and the previous ones we've just done is we can see that there's variables on both sides. So I've got a 3x on this side and a 2x on the other side. Basically, what I like to do is to put all the variables on the left-hand side. You can do it on the other side, but I like to just do it. It makes it a bit easier. So I'll just leave it there like that. So again, our equal signs just go underneath each time. So just clear setting out what we're doing. So basically, I want to get rid of that 2x on the right-hand side there. So if I take 2x from the right-hand side, I've got to take 2x from the left-hand side. 3x take 2x is just one lot of x. And I've still got that plus 7, and I've still got that 13 on that side there. And then it's just a simple equation now. Just go get rid of the 7 from both sides. 13 take 7 is 6. And so that 1x is just x. X is 6. Okay, and let's test it out. 6 3s are 18. 18 plus 7 is 25. Test it out here. 2 6s are 12, 12 and 13, 25. Awesome. And final one here. So again, get all the variables onto the left-hand side. So I want to get rid of that minus 2a here, and I want to put it on the other side. So I've got to add 2a to both sides. 7a plus 2a is 5a plus 2a is 7a. Take 21 is equal to 14. I'll write out all the other values exactly as they are. I'm going to add 21 to both sides now. 7a is equal to 14 plus 21 is 35. And then 35 divided by 7 is 5. Cool. And again, sure, if you put it in, substitute it in, you'll figure out that that is true on both sides. You can also, show your steps along the way if you'd like. So I haven't done that here, but I could say, back up in this example here, what I did was subtracted 3 from both sides, and then over here I divided by -2. Here I could say for both sides of the equations I added 2a to both sides, and then here I added 21 to both sides, and over here I divided by 7. So you can show those steps if you like. You don't necessarily have to, but it gives you an idea of what's happening. And the key thing to keep in mind is that each line of your working is an equivalent equation. So each equation that you're doing for each line that you're doing for each one is the same equation essentially. All right, hope the video helps, guys.